So we've just established the impossibility of aggregating preferences without violating the axioms in Arrow's framework, which are reasonable properties that we would require a social preference relation to have. So is there any way out of this dilemma, and what are the implications of Arrow's impossibility theorem? Well, the first possibility is simply to accept the verdict that the social preference relation may not be rational. So we drop the rationality requirement, and what that does is really place emphasis on procedure, because if we accept the possibility of cycles at the social preference level, then what procedure we choose to determine the social relation will be highly relevant to determining a specific outcome over another. And this is actually our textbook's interpretation, or one interpretation of Arrow's impossibility theorem. I'm reading here from Mascalel, Winston, and Green on page 799. What Arrow's theorem does tell us, in essence, is that the institutional details and procedures of the political process cannot be neglected. Now, this is not really a resolution of Arrow's impossibility result, rather just a method of coping, preferring the outcomes generated by specific procedures over others might overcome the indeterminacy, but doesn't really address the fundamental problem or unsatisfactoriness of the choice procedure. So another possibility is to drop the universal domain requirement and accept that it may not be realistic that any possible preference relation be considered by the social welfare functional. So we may instead choose to operate with a restricted domain for preferences. And the example that is often given is that of single peak preferences. Single peak preferences. Now, if we restrict the domain to single peaked preferences, then we can show that the social preference relation will not be intransitive. So we avoid the intransitivities by restricting the domain to single peaked preferences. What are single peaked preferences? Well, there are preferences which are such that the utility falls off as you go further away from a preferred alternative. So if you consider, for example, the tax rate, right? And assume that, so here's a tax rate and here's the utility associated with a particular tax rate. Assume that you have a peak of preference. So you have a particular tax rate here, for example, T star, which is such that it is utility maximizing. So as you increase the tax rate towards that optimal tax rate, the utility associated with the rates increases, and seemingly it decreases as you fall further away from the optimal tax rate, right? So if there is one alternative here, T star, that represents the peak of satisfaction, the satisfaction increases as we approach this peak and decreases as we go further away. And specifically what we're ruling out is other peaks of satisfaction. So a situation like this where we have one peak of satisfaction and then another peak of satisfaction, that would be ruled out. Why? Well, you could see that the preferred tax rate is here, and you have your utility maximizing point, and so as you go further away from that optimal rate, the utility should be decreasing, but here we see that it starts to increase again, and you have the second peak here at this particular tax rate. So that is being ruled out here. A more formal definition could be given. The definition is that it's definition 21D3 in the book, Mascalel, Winston, and Green. And this definition is that if you have three rates, X, Y, Z, and if you have, let's say that X is the preferred rate, just could put here X. Well, if X is greater than, greater than Z and greater than Y, then Z is preferred to Y. This is a preference relation here. And if Y is greater than Z, which is greater than X, then Z must be preferred to Y. Right, because Z is closer to X, and Y is further away from X than Z is, so Z is preferred to Y. So this result, this is very closely related to what is known, I believe, in political theory as the median voter theorem, which is that if you restrict preferences to single peaked preferences, your median agent always exists and cannot be defeated by majority voting. In other words, if you take the median agent, the preferences of the median agent will govern the social preferences. So the social preferences will be identical to that of the median agent, and so since by definition the median agent's preferences are transitive and rational, so will be the social preference. Right? Now, why is this not a dictator? Why is the median agent not a dictator if this agent determines the social preference relation? Well, that's because median agent is not determined in advance. It's not one specific person. It changes all the time based on all the preferences in society. So that is one way out of the Arrovian impasse, shall I say. Now, we have other possibilities, which is to drop other axioms in the framework. So another possibility is to drop the pairwise independence requirement, also known as the independence of irrelevant alternatives. This axiom is not so uncontroversial. We can come up with examples of sensible ranking procedures that are reasonable and could be defended and yet violate the pairwise independence requirement. One example of such procedures is the board account. Now, I don't want to spend too much time on it because Sanjay does talk about it in his lecture, but I do want to go over with you a little bit why it is that the board account violates the pairwise independence requirement. Now, as you might know, the board account ranks an alternatives as a function of the rank of every other alternatives. So you can assign scores. So if you have 3 persons, for example, person 1, 2, and 3, and person 1 prefers A to B to C, person 2 prefers A to C to B, person 3 prefers B to A to C. All right. Well, what would you do? So for each alternative A, B, and C, you would assign a score which depends on whether it's the most preferred alternative, second best alternative, or least favorite alternative. So preferred alternative would get a score of 3 here. Here A is again the most preferred alternative, so it gets another 3. Here it's the second, so it gets 2. B here gets 2, 1, 3. C gets 1, 2, and 1. And then you would add it all up. So you'd get a score of 8 for alternative A, 6 for alternative B, and 4 for alternative C. So you would end up with a social preference of A over B over C. But what I want to show you here is that the preference between A and B, the social preference between A and B, which depends on the scores obtained by A and B, also depends on where C ranks relative to A and B in the choice, or rather in the rankings for each person. If I were to modify these rankings slightly, preserving the preference ordering between A and B, but simply changing where C ranks. So for example, for the second person here, I could, A is preferred to B, and I could come up with a preference whereby C is preferred to A, which is preferred to B. I haven't changed how this individual feels with respect to A and B. Person still prefers A to B, but I have changed the ranking of C, of alternative C. And similarly here, I can change to B preferred to C preferred to A. Again, B was preferred to A, and B is still preferred to A, but I've changed the ranking with respect to C. Well, let's see how this would change the scores. The preference for person 1 has not changed. For person 2, A would now only get a score of 2, B would get a score of 1 still, and C would get a score of 3. For person 3, A would now get a score of 1. It's the least preferred alternative. B would get still get 3 points, and C would get 2 points. So overall, A now gets 3 plus 2 plus 1, that's 6 points. B also gets 6 points, 3 plus 2 plus 1, and C also gets 6 points. What's interesting to note here is that I am no longer able to decide that A is preferred to B. They're both getting the same score. So I have changed my social ranking between A and B, even though individual rankings between A and B has not changed, right? Pairwise comparisons. The results of pairwise comparisons between A and B has not changed, but it is the presence of a third alternative C and how the individual feels with respect to that alternative C that changes the social preference relation between A and B. And that's why the board account violates pairwise independence. Now, another possibility is to drop the Pareto criterion, which at first glance does seem like an innocuous assumption, right? It's hard to imagine how this would not be a desirable property of a social decision-making procedure. This said, this article, The Impossibility of a Paretian Liberal, which is in your reading, it's on the syllabus, does establish a very interesting result. This is another impossibility result. It establishes that it's not possible to both apply the Pareto criterion while at the same time allow individuals to be decisive with respect to at least one pair of personal alternatives. So the Pareto criterion is incompatible with some degree of minimal liberalism. Now, what does it mean for one individual to be decisive with at least one pair of alternatives? Well, these alternatives have to be personal, so they have to relate to something that should relate to the person's personal sphere. For example, sleeping on one's belly or sleeping on one's back, right? It's really hard to imagine why anybody in society would care whether you sleep on your belly or on your back. And even if they care, for whatever reason, they really shouldn't be able to weigh in, right? So you should be the one to decide whether you should sleep on your belly or on your back. So your individual ranking between those two personal alternatives should be decisive with respect to the social ordering. Well, Sen shows that this requirement for minimal liberalism is not compatible with the Pareto requirement. And that is a very interesting result, and I'll spend more time on this in the next tutorial. But I don't want to confuse you, right? Sand's impossibility of a Paretian liberal is a different result from Arrow's impossibility theorem. The reason that I bring this up here is simply to show you that it might be desirable in some situations to drop the Pareto requirement. And if that's the case, then if we can do away with the Pareto requirement, that may be one way out of Arrow's impossibility theorem, because that is one of the axioms required in Arrow's framework. So loosening that particular axiom could be a solution to Arrow's impossibility result in some situations. So up until now, what we've been doing is retain Arrow's framework, right, which is to conceive of social choice as being based on individual preference rankings. Retain this, but explore the possibility of rescuing the social decision from either dictatorship or intransitivity. Rescue the social choice by exploring the possibility of loosening, relaxing some of Arrow's axioms. But there is another possibility here, which is to interpret Arrow's impossibility theorem as far from showing that reasonable choice is altogether impossible, to interpret it as showing that it is very limiting and indeed almost impossible to conceive of social choice as being formed solely on the basis of the aggregation of individual preferences, which is what a social welfare functional is, right? Well, one key point here to make is that in Arrow's framework, we are operating within a very limited informational landscape. All that we're doing is we're looking at rankings, right? Social rankings. A is preferred to B, which is preferred to C, but we're not looking at the strength of these preferences. So we are precluding interpersonal utility comparisons, right? Because we don't know what utility gain would be achieved by choosing B over C or A over B. So when we're aggregating individual preference rankings, we're not taking into account these utility levels and gains associated with social states. So we are basically confining ourselves to, broadly speaking, some kind of a voting process, right? But perhaps this approach is ill-conceived. There is one example given by Amartya Sen which illustrates the limitation of the Arrovian framework. And the example is if you are considered splitting a cake between two persons A and B, and you have three possible cake allocations. You have allocation where A receives 99% of the cake and B receives 1% of the cake. You have an allocation where each party gets 50-50, split the cake evenly, and another allocation where person A gets 1% of the cake and person B gets 99%, right? So here the first entry is A's share and the second entry is B's share. So what are person's A preferences? Well, clearly A would prefer to get 99%, right? To splitting evenly, to getting only 1%. Person B, on the other hand, is the opposite, right? Person B would prefer the allocation where A gets 1% and B gets 99%. The second best alternative is the 50-50 split, and then that's preferred to, the least preferred alternative is A getting almost everything. Now, when you consider these individual rankings, what the social choice rule must basically decide, right, which social what the social ranking is and what is the socially desirable alternative here between these three possible alternatives. And what is not obvious, but what Sen demonstrate, is that the Arrovian framework only allows us to consider the 99-1 or 199 allocation. It rules out the 50-50 allocation, right? That may never come out as a desirable outcome. And this is part of a strategy of proof for Arrow's impossibility theorem, which I'm going to go over in another tutorial, which shows you that if a person is decisive over a particular pair, then that person must be decisive over all pairs and in effect become a dictator. So the social outcome that will be ultimately emerge as the preferred outcome will be the outcome preferred by either party. So we're basically considering either 99-1 or 199, right? Either A's preferred alternative, or B's preferred alternative. And the second best alternative for either party will never be considered. Well, that is not, it's not very clear why this is the case, right? Why is the 50-50 split entirely excluded from consideration? There are merits to this 50-50 allocation. I'm not saying it's the best allocation, but there are merits to it. Well, Sen's framework precludes it. So that is one limitation of the framework. And so, you could move away from the limited informational landscape and include other kind of information as being relevant for the determination of social choice. That's one possibility. Another possibility is so one possibility is you take into account cardinal aspects of individual utility, right? In order to capture, for example, the strength of preferences. That's one approach. And there are, of course, difficulties associated with this approach. There's a whole blog entry on our blog on the INET website. The blog entry is it's called Solomonic Judgments versus Sophists, Economists, and Calculators, and I invite you all to read it. So some of these issues are explored further in that blog entry. There are difficulties associated with taking into account cardinal utility, right? You'd have to have some kind of a common denominator of states of minds and interests, so there are difficulties there. Another approach is possibly to look beyond the utility framework entirely, and so compare social states by using some other criteria for evaluating them, and that may include non-utility information, right, about the quality of human experience and the desirable access to basic minimal requirements of well-being, and those could be defined objectively. That is really Sen's approach of the capability framework, which is discussed at great length in some of the readings in our syllabus. And here the idea is that you focus on the kinds of freedoms and the kinds of capabilities that are needed for people to achieve a fruitful life, and that's what guides your social decision more than individual views or rankings of social alternatives.